Triangle QRT is drawn on a square grid using lines PQ and QR. Draw a parallelogram PQRS. I suppose line P is already drawn because P looks like it's already printed. So PQ should have been there. I don't have a ruler. I mean, I can't use a ruler right now, but please use a ruler. Okay, so PQ is supposed to be printed already. Now, how do we draw the parallelogram? Now, parallelogram means that you have two pairs of equal lines and also two pairs of parallel lines, right? So how do you draw parallel lines? Using the grid, it's not like an estimation, but rather you should use a grid. Okay, so QR has to be the same as PS, right? And you need to have an idea of what the parallelogram looks like. So QR is the same as PS. How you move from Q to R will be how you move from P to S. Okay, how are you going to move from Q to R? So you are cutting across how many squares? When I say cut across, I mean like from one corner of a square until it sits nicely in the corner of the other square. So Q is here and it's cutting across all these squares until it sits nicely in a corner for point Y. So it's cutting across 4 squares horizontally. So I'll do the same for P. 4 squares away is over here. So cut from one corner all the way to this corner. Okay, so this is point S. Next, connect. Or you can do this. Let me show you in another color. Go to the right 4 times. Come down 1 time. Go to the right 4 times. Come down 1 time. Follow the same sequence and that line will be parallel and equal. Same for PQ. If you were to draw RS following QP, right? From Q is 1, 2, 3, 4. 4 to the left and 3 down. So R will be 4 to the left and 3 down. You'll end up at the same point. Okay, so this is how you draw parallel lines. Oh, for part B, what fraction of the area of this parallelogram is the area triangle QRT? Okay, so QRT, what is the area of QRT? The base is 4 units. Triangle, the triangle base is 4 units. And the height is 4 units. Okay, maybe just highlight. Oh. This is the base. And this is the height. Base is 4 units, height is 4 units. So half times 4 times 4 for the triangle. Then the parallelogram. The parallelogram can be split into 2 triangles. Which is PQS. So if I were to look at PQS, right? The base is here, the height is here. and the parallelogram is twice of that. The base is 4, height is 4. So for the parallelogram is 2 times of the triangle half times 4 times 4. So can you see half times 4 times 4 is the same as a triangle, but the parallelogram has 2 of that to form the area. So what fraction of the parallelogram is the triangle? Triangle is half of the parallelogram, so half. Drawn to scale. You're supposed to draw 2 lines, PS and SR, so that PQRS is a parallelogram. PQRS is a parallelogram. Okay, if it's a parallelogram, then QR must be equal to PS, right? So you just need to count how many times are we moving from Q to R. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 intervals, 10 gaps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here. Okay, so this is point S, label S. Then you draw the line. Okay, use a ruler for this. PS, draw PS and SR. Okay, SR. Here, like that. Okay, then measure QPT. I can't show you the measuring here right now, but the answer is supposed to be 78 degrees for QPT, angle QPT. Here. Label it EFG. Okay, so use a ruler for this. I can't really use a ruler here, but let's draw a triangle that's half the area. Now, half the area of the parallelogram, actually a parallelogram can be cut into half. Like this way. So EFG will look something like ABD. Okay, so cut across this way and then cut across this way. So EFG. Next, draw a parallelogram that is twice the perimeter of this. Label it WXYZ. Okay, so you want twice the perimeter, right? Oh, okay, it says here that the triangle and parallelogram should not overlap. All right, so let's look at the diagonals. You have this and this. You want twice of that. So AB is like that, right? Cuts across, or I can say it's 2 to the right, 2 up. So 2 to the right, 2 up. I want to double it. So another 2 to the right, 2 up. Okay, so that's twice of AB. Before I draw CD, I need twice of BC. Okay, twice of BC. BC is 4, so I need to go to the right by 8. 1, 2, 3, 4, 6, 8 here. Then from here, I do 2 down to the left, 2 down, 2 to the left, and then another 2 down, 2 to the left. Like that, okay? And then you connect. Okay, please use a ruler to do this. And then label it. Oops, W, X, Y, Z. Make sure they go in order, like in sequence. Okay, you can't have W, X, Y, Z. No, it has to go in sequence. Draw and label PQR such that it has the same area as ABCD and without overlapping. So we need to find a point R such that it has the same area as this. So what is the area of this? Okay, in terms of squares, right? How many squares? If we split it this way, I can say that this one and this one actually give you 1 square. And then this one and this one gives you 2 squares when combined. So total area will be 3 squares. So we need to find an area for this such that it gives us 3 squares. Okay, and this is the base. So this is 3. What is the height? How high do we need to go? Now, half times base times the height should give us an area of 3. So what is this missing number such that we'll end up with 3? Half times 3 times 2. Because half of 2 is 1. 1 times 3 is 3. Okay, so this missing number is 2. Your height of the triangle should be 2 units. You can put here R, then connect. This is one of the answers, or you can also put R here. You can put R here, you can put R here, you can even put R here. As long as the height is 2 units. That's all that matters. Okay? Okay, next, draw and label a parallelogram. ADEF such that DE is shorter than AD. Now, because they said AD, right? AD. So you need to use these 2 points. Not draw a separate one, but you have to use these 2 points. So these 2 points are one side of the parallelogram. Okay, ADEF. E is next to D. So DE must be shorter than AD. Okay, so just don't make it longer than AD. Maybe you can even just draw it here. So this is E, DE. Then just connect. Okay, parallelogram. So this is 1 to the right. And then connect this. Use a ruler when you're doing this. ADEF. So that's your parallelogram. If you draw it over here, it's still fine. DE will still be shorter than AD. So this is not the only answer. Actually, even if you put E over here, it's also correct. Not wrong. E over here, then it's a very thin parallelogram.
QRS such that it has the same perimeter as A, B, C, and D. So basically the same perimeter as this rhombus here. Okay, so one side of the square will be the same as one side of the rhombus. So how do we know, or how do we check this? So when you want to compare the length of a line, right, you can look at this here. Okay, maybe a bit light. Sorry, let me try again. Look at the line AB. It is a line that cuts through 6 squares. Okay, like a 3 by 2 square. Sorry, 3 by 2 rectangle made out of 6 squares. So same for SR. Okay, can say like it cuts across 3 and then like down 2. Okay, across 3 and down 2. So okay, maybe we look at it. Across 3 and down 2. For this one is down 3 and across 2. So then, since they cut across the same way, right? The length of SR and AB is the same. Okay, so the next thing to do is how do you draw a square using the same sides? And it has to be, for a square, right, it has to be perpendicular. So for SR to cut that way, you need to, in a way, like cut across the same manner. So for a perpendicular line, instead of cutting across 3 to the left, right, we cut 2, and then we go up 3. And that's your next point. We connect here. Here like that. Okay, then we do the same thing. Maybe from point, you can continue from this, either this point here or this point here. Let's continue from this point here. So I will cut across. It has to be the same parallel as SR, right? So I will cut 3 to the left, 2 down. So from here, 3 to the left, 2 down here. Here. 3 to the left, 2 down. So like that. Now you just need to connect this line here. Okay. Then because they say it's PQRS, it has to go in order. PQR, then S. If this is R, this is S, then this must be P. Q. So P, Q, R, and S. Okay, so to avoid confusion, let me erase all this first. Okay, all those markings you can do in pencil. So this is your answer for part A. Now for part B, what fraction of the area of rhombus ABCD is the area of the square PQRS? So firstly, I want to figure out, like, in that fraction, what should I be finding? First is the area of a rhombus. So what fraction of the area of the rhombus? So of the rhombus means that the rhombus below. And on top is the square. Okay, let's find the area. For the rhombus, right, it's made out of 2 triangles. The top triangle and bottom triangle have the same area. So the bottom triangle, rhombus, oops. Okay, for the rhombus is made out of 2 triangles. So we take 2 times, half times base times height. So half times, the base is here, A to C. So that's 4 units, 4 squares. Then the height is here, 3 squares. So two triangles. Okay, that's why the 2 is there. Two triangles. Okay, 2 times half is 1. 1 times 4 is 4. 4 times 3 is 12. So rhombus has an area of 12. Now for the square is a little harder to see. Usually for a square, you take like the side times the side, right? But it's impossible. It's not impossible, but over here, you are not able to find the length of this diagonal, this side, okay? Because it doesn't cut across the square along the sides. So we can't find this. But what you can do is to split the square into smaller triangles. Okay, let me show you how. So that it's easier to find the area of the triangles. So this is one triangle. Okay, and this is actually half of 6 squares. And you see it cuts. This is actually half of this rectangle, which is made out of 6 squares. Okay, so that one will be 3 squares, it's got 3 units. And another triangle here, 3 units. And then another triangle here, 3 units. And then another triangle here, 3 units. Then you have one in the middle, which is 1 unit. So for the square, it will be 3 times 4. Then you add the square in the middle. So that's 13. Okay, so square over rhombus. Square is 13 over 12, which will give us 1 and 1/12. Okay, it may not necessarily always be a smaller number on top, bigger number below. Okay, depends on what they're asking for. All right, that's for question 2.
Triangle. Such triangle means we are talking about same triangles. To form a parallelogram with the largest possible parameter. You see, for the longest side of the triangle is always this side, of right angle triangle is always this side. We call it hypotenuse of a triangle. This is the longest side. So we try to draw the parallelogram such that this side of the triangle is exposed. Is part of the parameter. Okay. So for those who got it wrong, I guess you do it this way, right? I guess you do it this way. What is it? This. Okay. I guess you do this way. One triangle. When you do this, what happens is that you will not get the largest or largest parameter as the hypotenuse of the triangle is hidden. It's not part, will not be part of the parameter. Right, you probably will do this. I don't know, 3 triangles, right? One triangle here, and then you draw another triangle here. I don't know, yeah, maybe another triangle here, then another triangle here. You get a parallelogram also. But you'll notice, one of the hypotenuse is hidden. You want it to get exposed. How to draw so that all the hypotenuse is exposed? This is how you draw it, one triangle here, and then you have another triangle here. 4. And then draw another one, which is here. So this exposed, this exposed, and this exposed. Correct? So this will be the largest possible parameter. Actually, not, no. Let me see, there's another way to do it, which is even bigger. Because I want to have, let me try again, sorry. If the grid is long enough, right? If the grid is long enough, you should draw it. There's no grid here. If there's a grid here, this will be even longer. Okay, if there's a grid here, then this parameter will be even larger than the one I draw before. Because if you look at the triangle, right, to make the parameter as large as possible, you want to expose this and this. Because this is the second longest line. This is the longest line of a side of the triangle. This is the second longest. I want to expose these two as much as possible. So but if I draw it this way, notice I expose the hypotenuse and the second longest line. The hypotenuse and the second longest line. Correct? But in my earlier diagram, I did not expose the second longest side. But that is because I can't. The grid do not have this column here. Okay, this grid stops until here. But if this grid extend to here, then the answer is this. You got it or not? If the grid extend to here, the answer will be like that. So, but because the grid stops here, then the answer is like that. You notice my second longest side is not exposed. This is the shortest side of the triangle. Okay. So this is draw three more. So this is how you do it. Then measure and write the length of the longest side of the parallelogram. So this is measured. If you measure it, it's about 10.2 centimeter. So you got the first question, part A wrong, you get part B wrong. Any question? So what do you learn from this question? You learn that if I want to draw a diagram using triangles, and the question is, I want the parameter to be as large as possible, try to expose the hypotenuse and the second longest side of the triangle. Okay? So that's for this question. Let's continue.
And AB is parallel to CD. BC and CD are half the length of AB. Draw trapezium ABCD. Okay, so we have AB. ABC is 90 degrees. So now how do you draw right angles? Look at this line here. Okay, this A to B, right? Okay, you don't have to look at A to B, but you look at how it cuts across squares. The smallest number of squares would be 3 squares. So it cuts across 3 squares, right? If you want to draw a line that is perpendicular to that line, it will also have to cut across 3 squares. So what I mean is like from here, right? We'll cut across 3 squares here. Please use a ruler. I'm not able to use a ruler now, but yeah. So this is right angle. Okay, 90 degrees. Then AB is parallel to CD. So BC, okay, I know C is in this direction, but I don't know how long is C, right? BC and CD are half of AB. So if AB is like that, right? BC has to be half of that. So this is exactly half. So C will be here. Okay, so that's C. Now C to D, CD has to be parallel. So let's draw a parallel line. A parallel line will cut across 3 squares as well. So this will be D. Okay, so this is D. So your trapezium should look like that. Then you connect this with a ruler. This is what your trapezium should look like for part A. Now for part B, EFGH. Now you have to draw EFGH. Parallelogram is the same perimeter as trapezium ABCD. So you're supposed to draw it such that it doesn't overlap with the trapezium. Okay, let's draw it here. Now, parallelogram means you have 4 sides and they have 2 pairs of equal sides, right? So look for, let's say A to B, right? You see the highlighted line, right? Let's take that as one set. How many of that do we have? So we have 1, 2. For AB, there's 2, right? And then BC is 1 more. And CD is 1 more. So total we have like 4 sets of that. Okay, if you have a parallelogram, you need to have 2 pairs of equal sides. So the 4 sets, we're going to divide by 2 sets each on 2 opposite sides. So example, if I were to start here, I cut across 3 squares here. This is 1 set. And then I cut across another 3. This is another set. So I have 2 of the yellow highlighted ones. I will have another 2 on the opposite sides. Okay, so I split them equally. Now, the other 2 sides will be using AD, it cuts across 2 squares and then 2 squares. So I will split it into 2 parts, which means that each part will look like this. Okay, so I will cut it like that, cut across 2. Okay, so you have 2 parts. This will be the other side, cut across 2 like that. Then now you connect. So the other side should be the same, cut across 3, cut across 3. Okay, then you can label them E, F, G, H. That's how you ensure that the sides are all equal. Okay, not very straight here, but use a ruler for yours.